Hello, everyone. I'm Lishan. I'm a solution architect in Alibaba Cloud. So today I'm going to show the solution about end-to-end cloud-native application management on Alibaba Cloud. So firstly, let's see what is cloud-native. So cloud native, you can understand that has three characters. The first one is around application to provide application lifecycle management and make application be robust. So the second one is make it easy to use. And the third one is saving cloud resource cost and improve operation efficiency. So which technical that can achieve that three character, you can understand that it's cloud native target. So for now, when we talk about cloud native, we should talk about the container first. And we know the container platform nowadays, Kubernetes is very popular. And this is a forest wave, the newest forest wave. The forest have 3 points to evaluate each container platform. So you can see Alibaba Cloud in the leaders quadrant. So you can see Alibaba Cloud have a strong current offering. So I will show you what is we provide. So the managed Kubernetes service is fundamental, and except managed Kubernetes, we provide 5 layers ops ability to help you easy to use it and saving your cost and improve operation efficiency. So that is what's mean. We provide, okay. And when we see each of the ops, so we will go through each of them. Like cloud ops that the target is cloud environment build and cluster management. So the cluster management, it can be one cluster or multi-cluster in multi-region or the cluster in multi-cloud. So that is okay for, that is the in charge of in cloud ops to do. And the second part is DevOps. So DevOps, the major ability is application deployment and image management and application monitoring and tracing. So through that features to make you easy to deploy your application in one cluster or in multi-cluster, and through application monitoring to let you know what is happened for your applications. Okay, and the second part is SecOps. So you can understand SecOps is for security department. Someone use it. So that is the major ability is fine-grained security control. So from the security control to make your cluster will be secure. And the next one is AI Ops. So that is we provide some tools and service to prevent your cluster risk and solve some abnormality problems. And the last one is FinOps. So we provide features to help you analyze your cost and control your cost. This is architecture. It's about all of that feature around containers. So like I mentioned, the application running on ACK, and we leverage each of those features to achieve the 5 layers ops. Okay, so next I will show you each of them. So because we do not have enough time, the basic feature I will quickly go through. Okay, and finally, you could find the white paper from here, and you could find all of the features, how to do that, and have a demo step by step how to do that. Okay. Okay, so this solution, I use the real microservice application. So let's see the microservice application. So these have two applications, the app and Jupyter, and each application have the 4 functions. Okay, and this function called RabbitMQ, and I use Spring Cloud Gateway to access the application and use NICOs to do the service discovery and the registration. And the database, I use the MySQL. So originally, all of that service build to a jar package. So the first step is use cloud service to instead of the each jar package, which is not relevant with your application. Okay, so what is your application? It's just here. So that is your application business logic code. So you're writing here, but other is other services. So instead the cloud services to use cloud services to instead that package. So that means you do not to maintain other services. Okay, so you do not to check whether RabbitMQ can be work, whether the MySQL is it work. So you do not worry about that. That's the focus on your application code. Okay, so the MySQL use DS MySQL instead of, and we provide the DMS data management. That is have a UI, friendly UI that makes you easy to manage your database. And use RabbitMQ, manage the RabbitMQ, and use MSE to do the cloud native gateway and the service discovery registry, and all of the application log stored in log service. So through these use data services, so you could get some benefit like reliability, efficiency, and stability. Okay. So let's go through each of the ops. The first one is cloud ops. So we know that first we need to provision our services, and our major services are we integrated with Terraform. So from this URL, you could find all of that resources and have an example how to do that. And also we provide a model for Terraform. So that's easy to use. You just call the model. You do not write so many code to provisioning your cloud services. Okay, so next one, let's see auto scaling. For auto scaling, we provide 2-layer auto scaling. The first is cluster auto scaling, and another is HPA, the pod auto scaling. So in pod auto scaling, you could define your CPU memory usage, or from like latency or QPS to trigger the scale. And the cert manager, you can understand that it help you achieve HTTPS access. Okay, so and the cert manager is they support some major issuers. Okay, so through these issuers, they create a certificate, and the cert manager also integrated with ACK. So you could leverage the cert manager to make your application be accessed by HTTPS. Okay, so for this cert manager, we provide 2 validation. The first one is HTTP validation, and the second one is DNS validation. So HTTP validation support ingress, and when you create just create a cluster issuers, that's all, and the certificate and the secret will be auto created with ingress. If you have your own DNS and you want to HTTPS to bind your DNS, so you could create LDNS webhook and issues and create your certificate and secret, and those that support ingress or support service mesh. Okay, so next is the external DNS. The external DNS is it's very easy to use, just to update your YAML file, your deployment YAML file with service and all ingress, and the DNS record will be automatically added in DNS or in private zone. So all of that is when you move your application on cloud, that features you should use, you will use. So next part, let's see the observability. We know the observability is very important for cluster, for Kubernetes cluster, because Kubernetes is very, it's not easy, it's so complex. So we should know what is happened in the Kubernetes cluster in any time. So for log service, we provide the out-of-box some dashboard. All of dashboard you can open to use. Just when you enable Kubernetes cluster, when you create a Kubernetes cluster, just select, do you want to create that dashboard? So all of that dashboard will auto-create it for you. So that's include the Kubernetes cluster dashboard and Kubernetes Event Center dashboard. Okay, let's see some screenshot. So this is Ingress Access Center. So from here, you could see PV, UV, something, and this is Kubernetes Event Center. You could see what event happened for your Kubernetes cluster. For example, the image pool failure or port pending. So all of the event will show in this event center. Okay, and also you can query your event. And this is ingress overview, include except PV/UV, also include latency. And like I mentioned in the auto scaling, that it support the metrics. So that it can metrics the metrics can be the latency. Like this, maybe so you can set in the latency more than 10 milliseconds. That will be auto scale. That's okay. Okay, that's it. Ingress monitoring to see what the exceptions, the ingress exceptions, and also other metrics. Okay, and this is the you can understand that will scan your Kubernetes resources, which is not follow the Kubernetes security best practice. Okay, if it's not followed the security best practice, so you will see that have some warning or error items here. So for the detail, I will show you in the later. I will show you later in the SecOps part. Okay, so next, let's see the multi-cluster and the multi-cloud management. So like I mentioned, so Alibaba Cloud, the ACK provide the feature is multi-cloud management. So it can be on your IDC or the Kubernetes in other cloud vendor, it's okay. So you can register in the in ACK and use those features to manage the register, the cluster. So this is one of the scenario about multi-cluster management and to achieve disaster recovery cross region. So we have a feature, or we have a brand called ACK1. So ACK1 is dedicated for multi-cloud and multi-cluster management. Okay, so from here we can see our application. So this have two reasons. The reason one is that the application is active mode, and the reason two is a backup node. So for generally the reason one, the application application deploy in the two clusters. Okay, and leverage the global traffic manager to citing the traffic from here and from here, the separate is 50%. And when this region, something happened, this region cannot be work, and that will auto to traffic to switch traffic to this region. Okay, and ACK1 can deploy the application one time in the different region. Okay, even this sometimes even this cluster is from other cloud provider, it's okay. Yeah, okay, and maybe sometimes so you can imagine maybe this region connect the RDS the endpoint is different than this region. So you can configure that you can understand how a config file so to allow you configure the endpoint some setting and just deploy once time and then that will the application will deploy in different cluster. Okay, and follow the different configuration. So next part, let's go through the DevOps. Okay, so we provide the ACR Enterprise Edition. So for ACR EE, it has some, you can understand that it's image management. If your application in different region, so you could use image replication to automatic replicate image to different region. Okay, and you could use image signature to make your image be secure. Let's see, that is a delivery chain. So you can enable or disable each of the steps. The first one is to build the image and scan the image and to setting whether you want to sign the image to make the image be secure, or do you want to replicate? And finally, it can be deployed in ACK. With this is a workflow of image signature. So leverage those cloud service to sign your image. And all of that just we also have UI and script to enable you easy to use it. Okay, and the next part is application center. So application center that is manage the Argo CD. So that can the image center is based on GitOps concept to make you easy to deploy application in different cluster. Okay, so this repo stored your config file, your deployment, that is YAML file, and when you submit that's code that will auto trigger application center and deploy in different cluster. And also application center is integrated with ACIEE, and will have a new version image push. The ACIEE can be triggered to auto deploy the new version image of application. So let's see what it looks like. That's the 3 steps. The first step to select the source from Git or from your local template or from the Helm chart. And the second one to setting, so this is I select the Git repo. And the next one to tab, which is your Git. And the third step to select which cluster you want to deploy your application. And finally, you got the deployment topology to see what application has been deployed and which is a failure, which is a success. Okay, so next one is about service mesh. We manage the service mesh. The service mesh, we know service mesh have to layer the control plane and the data plane. So control plane part is managed by Alibaba Cloud, and the data plane, it can be in ACK cluster or serverless Kubernetes cluster or ECS VM or edge cluster or external register cluster, which one is the cluster on your premise or in other cloud vendor. Okay, and we know service mesh is a little bit hard. So we also provide the friendly UI to make you very easy to create your service mesh. Just follow this UI and to select which feature you want. And the next is add the ACK, which you want to have service mesh ability. So let's see some scenario. The first one is a cross-region traffic manager. So that is your application deploy on different region, and so that is 4 steps to achieve that. The first one, deploy your ACK cluster in different region and deploy application cross ACK cluster in a different region. And the third step is create ASM gateway in different region. Okay, and the last step is configure GTM to access the policy based on geographic location or based on latency. Okay, so that's all. Yeah, and the next scenario is about traffic distribution or failover. So let's see this one. So sometimes we know that our application is microservice. And sometimes maybe this microservice cannot be accessed. So for that can be failed over to another cluster to access this microservice. And you can configure this microservice access to other service by this region or by this cluster or by another cluster to fall back to the original cluster, so that this can be do, or you can separate the traffic distribution. Okay, and the next the scenario about the kernel or A/B testing. So for example, these services deploy in the product environment, but you have one service want to do the A/B testing. So how to do that? Just deploy one service and configure something, and that service B will access this service C, and finally the service C will fall back to service D. So achieve that, use service mesh to achieve that you do not need to update your product code, just to update your YAML file, to deploy YAML file. That is easy to achieve that. So that is why some enterprise, they are trying to adopt a service mesh. And the next one is MIC. So like I mentioned, the MIC that can be managed service discovery and cloud native gateway. So this gateway can be the ingress gateway or the internal gateway. Okay, so just create a registry. The engine can be Nichols or Zookeeper. Yeah, and you will got the URL from here. So that's all. That's it. You got the service registry, the service discovery. Yeah, and the next is just create a gateway. And create gateway. You after that you got the access URL. Yeah, and to create a source, the service from Nichols or from ACK container. So that's it integrated simply, very easy to use that. And just access here, just access the URL, you will to access your application. So next part, let's see the application monitoring. So for DevOps, for DevOps, it's not only about the CI/CD. It's also we need to provide some tools or service for developer. So when your application running on product environment or test environment, some error happened, but the developer don't know why all these error, it cannot be happened in the local developer environment. So that is we need application monitoring to check a look to find out what reason of the error happened. Okay. So install the application monitoring. It's also very easy. Just follow the 2 steps. And you will got the managed application monitoring. So from here, you could see each of the services that is response time and did you have some error happened, and you could find the total request and that is what's the access path, what's the microservice access path. Okay, and from here, you could find one of the service to take a look at the trace. Yeah, from here you can see the trace is receive MQ message. Okay, and also you could find the error analysis from here to analysis what happened from error, and also have GM monitoring. So all of that, you do not to install your own monitoring service, just use managed. That is saving your operation time. Okay, also from here, you could see one service that's the invocation path. Okay. And we also provide a tracing that is based on OpenTelemetry. So I think maybe you know what is OpenTelemetry. That is, you can understand that is the standard, the rule about to make each tools to have the same same rule to help the customer use the telemetry data such as trace, metrics, and logs. And these features is OpenTelemetry provide, and log service provide those features to help you extend the OpenTelemetry ability to help you easy to find your metrics and log to make the metrics and log together to help you find your error. So let's see an example. This is a screenshot about the trees overview. So from here, you could see the trees span and how many services here, how many methods. And in each service, you could see the service, the QPS, and error rate. And the trees, it can be queried. So you could query by a service, or you can query by a business logical. For example, if you are an e-commerce platform, so I think you should have order ID. So you could query by an order ID to trace what happened by this order ID. So you can find what's the link, what's the what's the core path or something. And each of the service has a different color line and easy to get the span time and detail info. And from here, you could see the each services use which language to build that. And we know the application. So we have so many customers nowadays, they use microservice to build this application. But to know the microservice home picture is hard to do that. So we provide the trace topology based on the trace data to build a microservice topology. So from here, you could see all this web access this front end, and the front end access the user. And you could also know the QPS and average latency, some info. Okay, so let's see a scenario how to use trace to find error root region. So firstly, we query about error. For example, this status code is error. And when we click error, we see, oh, this method have an error happened. And from here, we could see some logs here. And in the details tab, have a trace ID. So when we click trace ID, that will forward to the log info. So that's in the same console. You do not have to switch different services to check what is the trace ID and copy the trace ID to log service and to paste the log service to find what's in the log to see the details. So you do not need to do that. Just from here, you can to achieve that feature in one console. Okay, so from trace to link to the log, and also from any log you can link to the trace ID. And in the log, how an item is caller. So you could add event for this caller to add your code URL from here. So that is we can imagine from arrow to find the arrow method happened to see the log, the tail log, and from log to find the code. So that is we provide the tools to make you easy to find the arrow root code, the root reason. Also, you could build your own dashboard from Trace ID. Yeah, if you feel our existing dashboard is not enough for you. Yeah. And how to use that ability? Just a 3-step: the install it and create a trace instance in log service and deploy CRD here and deploy instrument. So that's all. So you will get the traceability. So next part, let's see the SecOps. The SecOps include some features. The first one is secret manager. So we know ACK have a secret that stores some sensitive data. For example, applications password. For example, the database password and username, or other services password. But maybe we don't want to store that secret in Kubernetes cluster. So we want to leverage another secret manager service to store that secure. Okay, so that is why have those features leverage external secret to store the secret in KMS. Yeah, and also that is very easy to use in ACK. Yeah, just create them. Add policy in ACK and install ACK secret manager. Yeah, that's all. Okay, and another part is about policy government. So when we talk policy government, we should know the two tools. The one is OPA, another one is Gatekeeper. So OPA is short named by Open Policy Agent. So that is a policy as code, the concept to make you write code to manage your policy. Yeah, and the Gatekeeper is parameterized policy library. But you know that even OPA or Gatekeeper, that is very hard to write the code. Even the expert, they need to write maybe several days to achieve OPA template. Okay, so what we did, so ACK provide various kind of policy templates by default. So you do not write your code, just in this template to enable that feature or disable that feature. So that's all. So now we provide 35 policies, and the policy will add it in the future, add more in the future. For example, this is sometimes our customer, one of our customer side, we want to developer team or operation team to create their own SRB service. We want to application can be accessed to internet. Okay, so for that scenario, you could enable this feature. The load balancer service cannot be deployed in a special namespace. Okay, and when you enable it, so you could define the action, block it or alert it, and define which namespace will apply this policy. So for example, this is block. And when you create a service with SRB, you will facing this arrow that show you have no permission to perform this operation. So that is easy to use. You do not write your own policy code. And the next one is zero trust. So zero trust is you can understand that the application between application is not trust each other. You should authorize of them and that can communicate. Okay, so you could define this namespace, and this namespace that is can be accessed by a namespace or IP block or path or hosts. Okay, and also a GTW token to access each other. Or this application can be access this application by the TLS. Okay, let's show a demo is here. This namespace cannot be accessed RDS. Yeah, okay, so that is configure the external access policy and the service entry. Yeah, and from here, you just configure this namespace. When this namespace access RDS, it can be denied or allowed. Yeah, so that's all. Okay, so let's see the result is that is when the namespace the run MySQL connection, so you will see the lost connection. Okay, and without authorization, so you could see the policy result. Okay, so thanks everyone to join this session because we do not have enough time to talk about AI ops and the FinOps, but you could find from here Alibaba Cloud, the solution by user case. This is end-to-end cloud native applications management. And from here, you could download the white paper to show each of the feature of that. Okay, thank you, everyone. Bye-bye.